All right, everybody. With this video, there will be a big turning point in our class because we'll begin to talk about something called the normal distribution. And much of what we do from now on will concern the normal distribution. It's very important in the world of statistics. It's a very common feature of many different kinds of problems that people try to solve and understand. Okay, so in this video, I'm not going to do any math. I'm not going to show you how to do any math. It's conceptual. I need you to know some basic facts and get used to seeing this curve and some features that are on it. Okay, so the normal distribution is sometimes people call it a bell curve. Okay, it looks like this. Now, we've talked about the mean of a data set or a random variable. You can think of the mean as another word for the average. So the mean is right in the middle of this. I know I haven't told you very much about this yet, and it's like the whole picture will kind of come together as we do some examples, but I've got to tell you little by little, okay? So the normal distribution looks like this. There's a horizontal axis. The mean is right in the middle where the peak, the highest point is, okay? And you don't have to think of the normal distribution as a graph, but that's typically how we do it, right? I mean, because it's easy to think visually, okay? So now here are the properties of this graph, all right? The bell curve, we could call it a bell curve, I guess, is symmetric about the mean. So if I were to draw a line right down the middle, where the peak is, being where the mean is located, it would be symmetric. And by symmetric, I mean that this curve is a mirror image of itself on either side of the mean, okay? Meaning this side does not look different than this side. It's not skewed, it's not leaning in one direction or another. It's perfectly symmetric down the middle, okay? Now, still, like, I haven't told you what we do with this, but I'm just saying, like, that picture, that curve, that's called the normal distribution, and we're going to learn a few facts about it one at a time. Now, where does this come in? Now, it turns out that lots of types of measurements that, especially like things like the physical and mental characteristics of humans, are normally distributed. If you could, like, measure people's IQs or their weights or how fast they can run. I don't know, things like that. It's very commonly for things like that, physical and mental characteristics of humans to be normally distributed, meaning that the thing that ends up explaining those numbers is this curve. Okay, I haven't told you how yet, but that's where we're going. Now, here's something you'll be hearing a lot about: the area under the normal curve. Okay, and let me just say for now, the total area under that curve is 1. And by area, I mean just like, say you're going to buy a house or rent an apartment, how many square feet is it? Well, that's how big it is, right? I mean, you might say maybe you can get like I don't know, 1,200 square foot apartment, okay? That's the total area of the floor space, okay? So this is the same thing. You could measure the space under that curve that you see there, but it's always 1. I'll tell you why a little bit later, but let's say put that in our heads there. That's a fact that we might need to know at some point. And the way that we do things is that areas of different parts of this curve correspond to probabilities. All right, that's the main what the main thing for us to know is in terms of solving problems and understanding data. Okay, all right, and there is a mean and a standard deviation, and about 68% of the data is within one standard deviation of the mean. Most of the data is within one standard deviation of the mean. All right. Okay, so there's some facts everybody should know about the normal distribution. I know that like you don't really have any context for this yet because I haven't given you an example, but well, how about we do that? Like, what does the stat cat? This is just the kind of thing the stat cat would say. We really need an example to understand this. I would agree with that. Okay, so here's what I think is a real good example of a normal distribution. Okay, so suppose there's a recent study on world happiness, and participants were asked to evaluate their current lives on a scale from 0 to 10, where 0 represents the worst possible life that a person could be living, and 10 represents the best possible life, I guess complete euphoria all the time or something. The responses were normally distributed. So we'll always look out for that. You know, when something is normally distributed, that tells us a lot. That tells us we can use the tool of the normal distribution to explore the data, okay? Maybe make some predictions about it and so on. All right, now when we know some data is normally distributed, then the mean and standard deviation exist whether we know them or not, and it's nice if we know that too. So here I'm told that the mean is 5.2 and the standard deviation is 2.3. So anyway, so here's the bell curve, here's the normal distribution for this data, okay? The mean's right there in the middle, 5.2, right? Isn't that what it said? What's that mean? That's like your average person's response, about 5.2. All right, you know, maybe like most people, you have a response to this questionnaire being maybe a little less than 5 or a little more than 5, something like that. Okay, that's just where the middle is. That's what that means. Okay, now so this gives us a way to visualize the data. Now, still, like I realize, I'm telling you this, that we can visualize the data by this curve. I haven't exactly told you how. Here's that picture again. So now I'll tell you how. So here's the same curve. All right, take this curve right here. Here it is down here. Now, I know how to calculate the area under this curve between 6 and 8, which you see highlighted in red. Okay, and I will, in the next video, show you how to calculate that number also. That number happens to be about 0.26, okay? So what that means is that the probability of a random person's response being between 6 and 8 on that questionnaire was about 26%, okay? So remember up here when I said, for the normal distribution, areas of various regions under the curve are equivalent to probabilities. That's how, all right? Now, I haven't told you how to calculate any of these numbers yet, and I'm not going to. I just wanted to show you this is what we're going to learn, okay? So I'll show you before I'll tell you. Now, so like that's kind of a neat thing, I would think, is that there's this study, all right, people rank their happiness on a scale from 0 to 10. Looks like on average, maybe their response was like 5 out of 10 for their happiness. But like, you know, I might wonder, well, how many people had like ranked their lives from 9 to 10? You know, that would be the area on this curve from 9 to 10, which I could also calculate. And I might wonder, well, how many people, you know, just like it says here, rank their happiness somewhere between 6 and 8. Well, of that whole study, about 26% of them did. Okay, and I can do all those calculations just by knowing 3 things: that the data was normally distributed, by knowing the mean, and by knowing the standard deviation. Okay, all right. So that's the introduction and basic facts about the normal distribution. Next video, we'll talk about how you calculate that number. It's really not hard to do, especially when we have StatCrunch and Excel and nice calculators and things like that that basically do it for us.